Good morning everyone. Today I am going to discuss with you how to find trigonometric ratios of multiple and submultiple angles. As you have discussed in your previous lectures, how to find addition formula, how to find subtraction formula, how to find sine of, in the last few lectures you have discussed this formula. Sine of a plus b is sine a cos b plus cos a sine b, and sine of a minus b is equal to sine a cos b minus cos a sine b. So this is addition formula and subtraction formula for sine function. Similarly, you must have discussed these formulas for cosine. So cosine of a plus b is cosine a cosine b minus sine a sine b, and cosine of a minus b is equal to cosine a cosine b plus sine a sine b. So with the help of these formulas, these addition formulas, we can find the value of sine 2a and cos 2a. So let's see how. Now sine of a plus b is sine a cos b plus cos a sine b. So in this, if I put b to be equal to a, what will I get? Sine of a plus a is equal to sine a cos a plus cos a sine a. So a plus a becomes 2a, and here you can see that sine a plus cos a sine a, this will become 2 times sine a cos a. So thus we get our first multiple formula as sine 2a, which is equal to 2 sine a cos a. So this is the first double angle formula. Here angle is 2 times a, so this is called double angle formula. So sine of 2a is 2 sine a cos a. For example, say we have to find sine 60 degree. So if I take a to be 30 in this expression, I will get sine 2 into 30 degree is equal to 2 times sine 30 cos 30. Similarly, if I want to find the value of sine 120 degree, then I will take a to be 60 degree here, and I will get sine 2 into 60, that is sine 120, and it is equal to 2 sine 60 cos 60. So sine of 2a is 2 sine a cos a. Similarly, we can find cos 2a. So we know this formula, addition formula for cosine. Cos of a plus b is equal to cos a cos b minus sine a sine b. So in this again we put b to be equal to a. So what do we get? Cos a plus a is equal to cos a minus sine a sine a. Now cos a into cos a is cos square a, sine a into sine a is sine square a. So what do we get? Cos 2a is equal to cos square a minus sine square a. So this is the double angle formula for cos. Cos 2a is cos square a minus sine square a. We can find the equivalent forms for this also. This is well known property that cos square a plus sine square a is 1. So from this expression, cos square a will be equal to 1 minus sine square a. So if I put cos square a is equal to 1 minus sine square a, what will I get? Cos 2a is equal to 1 minus sine square a minus sine square a. So that becomes 1 minus 2 sine square a. So this is the equivalent expression for double angle formula for cos 2a. Cos 2a is 1 minus 2 sine square a. Similarly, if I put here sine square a to be equal to 1 minus cos square a, then I will get cos square a minus, I put sine square a to be equal to 1 minus cos square a. So it will become cos square a minus 1 plus cos square a. So it becomes 2 cos square a minus 1. So these are the three equivalent forms for double angle formula for cosine. So cosine 2a is cos square a minus sine square a, which is equal to 2 cos square a minus 1, which is equal to 1 minus 2 sine square a. Okay, similarly, we can find the double angle formula for tan. Now, as you have done in the lecture of addition formulas, that tan of a plus b is tan a plus tan b upon 1 minus tan a into tan b. Again, in this expression, if I put b to be equal to a, we get that tan a plus a is equal to tan a plus tan a upon 1 minus tan a into tan a. So tan a plus tan a becomes 2 times tan a, and tan a into tan a becomes tan square a. So what do we get? Tan of 2a is equal to 2 tan a upon 1 minus tan square a. So this is the double angle formula for tan. So let us recall all these double formulas. So sin 2a is 2 times sin a cos a. Cos 2a is cos square a minus sin square a, which is equal to 2 cos square a minus 1, which is equal to 1 minus 2 sin square a. And tan 2a is 2 tan a upon 1 minus tan square a. Now with the help of these double formulas, we can find sin expressions for sin 3a, cos 3a, tan 3a. Let's see. So suppose I have to find the expression of sin 3a. So what do? I will write 3a as a plus 2a. Now I know the addition formula. I know that sin of a plus b is sin a cos b plus cos a sin b. Now in place of b, now we have 2a. So this expression becomes sin a cos 2a plus cos a sin 2a. Now putting the values for sin 2a and cos 2a in this, we get the expression for sin 3a. So what was the expression of cos 2a? 1 minus 2 sin square a. And what is the expression for sin 2a? It is 2 sin a cos a. So putting the values here, so what do I get? This is equal to sin a times 1 minus 2 sin square a plus cos a times 2 sin a cos a. Now opening these brackets, we get that sin 3a is equal to sin a minus 2 sin cube a plus 2 sin a cos square a. Now again we can simplify this. We know that cos square a plus sin square a is 1. So from this expression, cos square a is equal to 1 minus sin square a. So I put here cos square a to be 1 minus sin square a. So this expression for sin 3a becomes sin a minus 2 sin cube a plus 2 sin a times 1 minus sin square a. Now simplifying this, I get this to be equal to sin a minus 2 sin cube a plus 2 sin a minus 2 sin cube a. Now sin a plus 2 sin a, this becomes 3 sin a, and minus 2 sin cube a minus 2 sin cube a, this becomes minus 4 sin cube a. So the final expression for sin 3a becomes 3 sin a minus 4 sin cube a. So see, with the help of expressions of cos 2a and sin 2a, we are able to find expressions for sin 3a. So let us recall it. So sin 3a, suppose we have to find the expression for sin 3a. So I write 3a as a plus 2a. Now applying the addition formula, I get this to be equal to sin a cos 2a plus cos a sin 2a. Now we know that cos 2a is equal to 1 minus 2 sin square a, and sin 2a is equal to 2 sin a cos a. Simplifying this, we get that sin 3a is equal to sin a minus 2 sin cube a plus 2 sin a cos square a. Again, putting the value of cos square a to be 1 minus sin square a, I get this expression to be equal to 3 sin a minus 4 sin cube a. So repeating this process, we can find the value of cos 3a. So let's see. So again, write cos 3a as cos a plus 2a. Now I know that cos of a plus b is cos a cos b minus sin a sin b. So this expression becomes cos a cos 2a minus sin a sin 2a. Now putting the value of cos 2a as 2 cos square a minus 1 and sin 2a as 2 sin a cos a, we get this to be equal to 2 cos cube a minus cos a minus 2 cos a sin square a. Now again we know that cos square a plus sin square a is 1. So sin square a becomes 1 minus cos square a. So putting the value of sin square a as 1 minus cos square a, I get that the expression of cos 3a becomes 2 cos cube a minus cos a minus 2 cos a 1 minus cos square a. Simplifying this, we get that cos 3a becomes 2 cos cube a minus cos a minus 2 cos a plus 2 cos cube a. Now 2 cos cube a plus 2 cos cube a becomes 4 cos cube a, and minus cos a minus 2 cos a becomes minus 3 cos a. So expression of cos 3a becomes 4 cos cube a minus 3 cos a. So this is the expression for cos 3a. So write 3a as a plus 2a, apply the addition formula for cosine, and then put the values of cos 2a and sin 2a. Similarly, we can find the expression of tan 3a. We will come to that. So first of all, let's see some examples. So suppose I have this question, sin 2a upon 1 plus cos 2a. I want to show that this is equal to tan a. Suppose I have to prove this. Now this is double angle formula, this is double angle formula. So what do? I want to show that left hand side is equal to right hand side. So first of all, I take left hand side. So left hand side is sin 2a upon 1 plus cos 2a. Now what is sin 2a? It is 2 sin a cos a. And what is cos 2a? Now see, we know that cos 2a has three expressions: cos square a minus sin square a, 2 cos square a minus 1, 1 minus 2 sin square a. Now here I use this 2 cos square a minus 1. 1 get cancelled with minus 1. So I am left with this 2 sin a cos a upon 2 cos square a. So 2 get cancelled with 2. 1 cos cancelled with this. So I am left with sin a upon cos a, which is equal to tan a, which is equal to right hand side. Okay. So let's see. Suppose we have to prove this. Sin 2a upon 1 plus cos 2a is equal to tan a. So first I will try to solve left hand side. Sin 2a upon 1 plus cos 2a. What do? I put the expressions for sin 2a and cos 2a. So I write sin 2a as 2 sin a cos a plus upon 1 plus 2 cos square a minus 1. 1 get cancelled with minus 1. So we are left with 2 sin a cos a upon 2 cos square a. 2 get cancelled with 2. Cos a get cancelled with cos square a. So we are left with sin a upon cos a, which is equal to tan a. Okay. Let's see the next exercise. Tan a upon 1 plus tan square a is equal to tan 2a. So now let's first try to solve right hand side. 1 minus tan square a. This is the expression, okay. No need to solve this, sorry. This is easy to do. Now let's try to solve this. That 1 minus tan square a upon 1 plus tan square a is equal to cos 2a. So in this also I will first solve left hand side. So left hand side is 1 minus tan square a upon 1 plus tan square a. Now we know that tan a is sin a upon cos a. So I will write this as 1 minus, it becomes sin square a upon cos square a, 1 plus sin square a upon cos square a. Now in the numerator I take the LCM cos square a. So it becomes cos square a minus sin square a upon, in denominator I also take the LCM cos square a. So this becomes cos square a plus sin square a, right. So this cos square a get cancelled with this cos square a. So we are left with cos square a minus sin square a upon cos square a plus sin square a. Now cos square a plus sin square a is 1. So this is equal to cos square a minus sin square a, which I know that equal to cos 2a, which is equal to right hand side. So thus we have proved that 1 minus tan square a upon 1 plus tan square a is cos 2a. Okay. So let's try to solve some more problems. So suppose I have to solve this 1 plus sin 2a minus cos 2a upon 1 plus sin 2a plus cos 2a is equal to tan a. Suppose I have to prove this. So in this again I will try to solve left hand side first. Now in left hand side we have 1 plus sin 2a minus cos 2a upon 1 plus sin 2a plus cos 2a. So I put the expressions for sin 2a and cos 2a in numerator and denominator. So it becomes 1 plus sin 2a is 2 sin a cos a and minus 1 minus 2 sin square a upon 1 plus 2 sin a cos a plus 2 cos square a minus 1. So have you noticed that in numerator I have used 1 minus 2 sin square a and in denominator I have used 2 cos square a minus 1 because I want to get rid of this one. So left hand side becomes 2 sin a cos a plus 2 sin square a, and denominator becomes 2 sin a cos a plus 2 cos square a. 1 get cancelled with 1 in numerator as well as in denominator. Now as you can see in numerator what is the common thing? 2 sin a. I take this 2 sin a common. So what is left? Cos a plus sin a. In denominator 2 cos a is common. Sin a plus cos a, right? 2 sin a. I take this 2 sin a common from the numerator. It becomes 2 sin a into cos a plus sin a. In denominator 2 cos a is common. So 2 cos a into sin a plus cos a. So this get cancelled with this. 2 get cancelled with 2. So what is left? Sin a upon cos a, which is equal to tan a, which is equal to right hand side. Okay. So let's try one more question. So prove that 1 minus sin 2x upon 1 plus sin 2x is equal to tan square 45 minus x, 45 degree. So in this I will try to solve right hand side first. Now you know that tan of A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. So what will be tan 45 minus x? It will be tan 45 minus tan x upon 1 plus tan 45 degree into tan x. Now tan 45 degree is 1. So this is equal to 1 minus tan x upon 1 plus tan x. Right? Now what do I want? I want its square. So therefore tan square of 45 minus x will be equal to 1 minus tan x upon 1 plus tan x whole square. Right? Now again I write tan x as sin x upon cos x, 1 plus sin x upon cos x, and then whole square. Right? I have written tan x as sin x upon cos x in the numerator as well as in the denominator. So this becomes cos x minus sin x upon cos x upon cos x So this is equal to cos x minus sin x upon cos x plus sin x whole square. Right? So this is equal to cos square x plus sin square x minus 2 cos x sin x upon cos square x plus sin square x plus 2 cos x sin x. Right? Now cos square x plus sin square x is 1. And 2 sin x cos x is sin 2x. Again in the denominator, cos square x plus sin square x is 1 and 2 cos x sin x is sin 2x. So this becomes 1 plus sin 2x, which is equal to right hand side. So let's see. The original question was, I have to show that 1 minus sin 2x upon 1 plus sin 2x is equal to tan square of 45 minus x. So what I have done, I have started with right hand side. So I have written first expression for tan 45 minus x. So this is equal to tan 45 minus tan x upon 1 plus tan 45 tan x. So this is equal to 1 minus tan x upon 1 plus tan x. So thus tan square 45 minus x is equal to 1 minus tan x upon 1 plus tan x whole square. So simplifying tan x as sin x upon cos x, I have written this to be equal to 1 minus sin x upon cos x upon 1 plus sin x upon cos x whole square. So this becomes cos x minus sin x upon cos x plus sin x upon cos x. Cos x get cancelled with this cos x. So we are left with cos x minus sin x upon cos x plus sin x whole square. So simplifying this, I get this to be equal to cos square x plus sin square x minus 2 cos x sin x upon cos square x plus sin square x plus 2 cos x sin x. Now cos square x plus sin square x, this is equal to 1. So this is equal to 1 minus, now 2 cos x sin x is sin 2x. So this is equal to 1 minus sin 2x. Again in the denominator, cos square x plus sin square x is 1 and 2 cos x sin x is sin 2x. So this is 1 plus sin 2x, and this is what we want to prove. This is equal to right hand side. Okay. Alright. Now let's see some simple example. Suppose I have to prove that tan 15 plus cot 15 is equal to 4. So it seems a difficult problem that first we have to find the value of tan 15 and then cot 15 and then substitute, but this is not that. So let us first simplify tan 15 plus cot 15. You know that tan is sin upon cos and cot is cos upon sin. So tan 15 plus cot 15 becomes sin 15 upon cos 15 plus cos 15 upon sin 15. So what will be the LCM? It will be sin 15 cos 15. So in the numerator, what do I get? Sin square 15 plus cos square 15, right? Now sin square plus cos square, you know, is equal to 1. So this becomes 1 upon sin 15 cos 15. Now see, we know that sin 2a is 2 sin a cos a. So if in this I put a to be 15 degree, what do I get? Sin 2 into 15, which is 30 degree, will be equal to 2 sin 15 degree cos 15 degree. Sin 30, you know, is equal to 1 upon 2. So from this, what do you get? Sin 15 cos 15 is equal to 1 upon 2, which is 4. 1 upon 4, sorry. So therefore, what does this becomes? This will be equal to 1 upon 4, which is 4, and which is the right hand side. So see, with the help of formula for sin 2a, it is easy to find tan 15 plus cot 15 without actually knowing these two values. So a similar question to this is, okay, that we'll do later. So suppose I have to find the expression of cot 2a, and suppose I have to prove that it is equal to cot square a minus 1 upon 2 cot a. So cot is cos upon sin, you know that. So in this, I will first simplify right hand side. So right hand side is cot square a minus 1. Now cot square a will be cos square a upon sin square a. So I will write it as cos square a upon sin square a minus 1 upon 2 cos a upon sin a, right? So in the numerator, I take the LCM as sin square a. So it becomes cos square a minus sin square a upon 2 cos a upon sin a. Now 1 sin a get cancelled with this, and this becomes cos square a minus sin square a upon 2 cos a sin a. Now cos square a minus sin square a is, you know, it is equal to cos 2a, and 2 cos a sin a is sin 2a. So this is equal to cot 2a. Simple. Right? So now you know how to find the expression of sin 2a, how to find the expression of sin 3a. Now with the help of these two, or with the help of this only, I can find the expression of sin 4a. How? I write sin 4a as sin 2 into 2a. So now this becomes 2 into 2a. Now I know that sine 2a is 2 sine a cos a. So this will become 2 sine 2a cos 2a. So putting the expression for sine 2a and cos 2a, I get the expression of sine 4a. Now suppose I have to find the value of sine 5a. So I can write 5a as